This video is going to be about solving mathematical inequalities. We're going to be given inequalities in maths which are written in a confusing way with lots of minuses and divides and multiplied, and we need to boil that down to a nice and simple inequality. This video hopefully will show you how you might do that. Solving mathematical inequalities. The first example, we might have a situation like 8x plus 5, let's change the colour, 8x plus 5 is greater than, and shall we say 21. Now that is an inequality, but it's a really confusing one. Like 8 times something, add 5 to that, and that must be greater than 21. If you try to say that to most people, they'll be like, what are you talking about? Can't you just tell me how many you need? So we're going to try to boil that down for them as mathematicians. First, let's get rid of that plus 5. It's almost like the reverse of BIDMAS. Usually it's best to get rid of the additions and subtractions, and then the multiplications and divisions, and finally any indices or brackets. Though that's not always the case, that's usually the order you do it in. To get rid of that plus 5, what do? Just like an equation, we do minus 5 to get rid of the plus 5. And almost all the techniques for an equation we're going to use for an inequality, they almost all work in the exact same way. We just need to remember that it's greater than, not an equal sign. What is 8x greater than? Well, now we've taken away 5, 8x is greater than, whoops, we don't know exactly. 8x is greater than, because the plus 5 and minus 5 have cancelled, 21 minus 5, which is 16. Still, it's a little bit confusing though. 8 times something is greater than 16. Can't you give me a straightforward expression? Okay, how do we get rid of that times by 8? We would divide by 8. And divide by 8, always to both sides, just like an equation. So we would have x is now greater than 16 divided by 8 is 2. And that's a whole lot nicer. Can I have more than 2 of something? That's a way easier to understand than can I have, if you times it by 8 and add 5, more than 21. That's confusing. Let's try another one. How's about we had something like 5x all divided by 3, and that dot shouldn't really be there, let's take that away. That is less than or equal to 7. Okay, less than or equal to. So there'd be a little line. Just to recap from my previous video, less than is the side which has its doors closed. So the 21 was less than the 8x plus 5 because it had its doors closed on the right here. The 8x plus 5 had its door open, so it's the bigger side. And when there's a line underneath, that means it could be equal to as well. When we solve inequalities though, the equal sign doesn't really make too much difference. We're going to just treat it like less than. Here we have no pluses and minuses to really get rid of. So let's get rid of that divide by 3. How would we get rid of a divide by 3? We would times by 3 to both sides. Times by 3 and times by 3. We use up the times by 3 when we get rid of that divide by 3. We would be left with 5x. Many students get confused, like why didn't you times the 5x by 3 as well? It's because, and let's just change these to x's just so you can see it more clearly. We're going to times by 3 to this side and times by 3. It's because we used up the times by 3 by getting rid of that divide by 3. If we then times the 5x by 3, it's like we've used it twice. So what simply happens is the divide by 3 just cancels out completely, and you're left with 5x. 5x is less than or equal to, still, 7 times by 3, which is 21. Finally, we divide by 5 to get rid of that multiplied by 5. So x is less than or equal to, so it's always going to have that line underneath, and don't be tempted to write just equals, which sometimes can happen. 21 divided by 5, which you can either do in the calculator or you can simply write as 21 over 5 as a fraction, so with a line in between. And there's our answer. Can I have less than or equal to 21/5 of something? Let's do one more. Let's solve one more inequality while we're at it. How about one with symbols on both sides? For example, 6y plus 3 equals to, oops, no, not equals to, is greater than, let's say, 5 into y minus 3, y minus 2. Okay, here's our inequality with symbols on both sides. My first step would be to times out the brackets, just to make it clear what we've got, what we're dealing with. Remember, our final goal is to have y is greater than or less than something else, just a simple letter and a simple number, not all this nonsense. Let's times out the brackets. To times out brackets, as you might remember, we do 6 times y and then 6 times 3. So we multiply everything inside the brackets by what's outside the brackets. 6 times y is 6y, and 6 times 3 is 18. So we get 6y plus 18. It's still greater than 5 times y is 5y. 5 times 2 would be 10. So 5 times minus 2 would be minus 10. Here we go. Which number should we get rid of first? Well, as minus 10 is smaller, let's get rid of minus 10. How would we get rid of minus 10? We would add 10 to both sides. That'll get rid of the minus 10. Notice, by the way, how I'm writing the add 10 underneath the two numbers. I'm not writing it next to the letters, the 5y and 6y. We should keep numbers and the letters very separate so it's clear what we're taking away from who. We're not taking away 10, or we're not adding 10 to the 5y to get 15y. 5y is in terms of letters, and the minus 10 and plus 10 is in terms of numbers, so keep them separate. Let's write the next stage down here, and we would get 6y plus 28, 18 plus 10, is greater than 5y. Who should we get rid of next? As it's smaller, let's get rid of that 5y. And I'm going to have to get rid of these guys and fill it in, just so we've got some space. Okie doke. So we have 6y plus 28 is greater than 5y. It doesn't really matter who you get rid of next, but let's pick on one of the letters. So let's get rid of 5y because it's smaller. So we do minus 5y to both sides. Minus 5y to both sides. So just to make it clear what I'm doing, minus 5y and a minus 5y. Not next to the 28 though. 28 is a number, 5y is the letter. So 6y, take away 5y here, becomes y. We still have the plus 28, and the 5y, take away 5y is 0. We're almost done. Notice how I kept the greater than, I didn't change that. Let's gently nudge that plus 28 to the other side so we have a nice neat conclusion. Y is greater than something. To nudge the 28, we do minus 28 to both sides, and our final answer, after we've solved the inequality, is y is simply greater than negative 28. Y can be anything bigger than minus 28.